fuel economy estimates for automobiles built in a certain year predicted a mean of 26.8 miles per gallon and a standard deviation of 5.2 miles per gallon for highway driving. Assume that a normal distribution can be applied. Within what range are 99.7 of the automobiles? Okay. This problem is talking about normal distribution. It says it right here, normal distribution, and that's the name of this curve, this bell-shaped curve down here. It's the normal curve distribution, and they're referring to normal distribution. So this is going to be very common. They're going to have several problems where they use this bell curve. So you want to put this bell curve on your notes for the next exam with all the percentages that are written on it. Let me explain to you what it is. It's called the normal distribution because it's what normally happens. What do I mean normally happens? Well, if we were to measure anything naturally occurring, we would find this kind of spread. Let me take an example. If we were to grab men's shoe sizes in the United States, and we were to say, okay, let's ask 10,000 men, let's find out their shoe size. There'd be some average. I have no idea what it is. Maybe 9. That would be right in the middle. See this X bar here? That means whenever you have X bar, that means average, middle. So that's the average, 9. I'm just making it up. I don't know what the average man's shoe size is, but let's say it's 9. Now, not every man is average. Some have bigger feet, some have smaller feet, some have really bigger feet, some have just a little bigger, some have really tiny, a little smaller. It's all over the gamut. Well, there would be some standard deviation. So let's just make up for men's shoe sizes. Let's just say that the average is 9, as I said, and the standard deviation, let's say it's 2. Now, what's standard deviation? I hope that makes sense. That's typical distance from the middle. Remember, we've talked about it a few times. Standard deviation is typical distance from the middle. So, in other words, not all men are average. Some have feet that are just a little bit bigger, some have feet that are a lot bigger, some a little smaller, some a lot smaller. Well, if the standard deviation is 2, that would mean that typically the typical distance from the middle, the typical man is off of the middle, off of the average, away from 9 by 2. He's either higher or lower, bigger feet, smaller feet, by 2 on average. That doesn't mean every person is 2 away from the middle. That's the typical distance from the middle, the standard deviation. It's not the exact deviation of any person. It's for all people, it's the average distance from the middle. Well, if that's the case, notice the standard deviations are these lines. This is 1 standard deviation to the right, 2 to the right, 3 to the right, and over here 1 to the left, 2 to the left, 3 to the left. These dotted lines are standard deviation jumps. What do I mean? Well, if you go from here to here, you go up 2. So from 9, this would be shoe size 11. What are we doing there? We're saying that the average man has a shoe size of 9, but not everybody's average. Some are above and below. The typical amount that they're off of the middle, typical distance from the middle, 2, standard deviation 2. So if you go 1 line to the right on this bell curve, it's a normal curve, that'll put you up 2, and then you can do another jump, goes up 2 again. This will be shoe size 13, and then another jump up 2. This will be shoe size 15. And then likewise, in the other direction, you can go down to, because this is just like a number line, except with 9 in the middle instead of 0 in the middle. Go down to, that's shoe size 7. So those are men with smaller feet, right, by the typical distance, which is -2. And then we do -2 again. Here, let me move it up so it's in line with the other ones. So -2 again, this would be shoe size 5. And then -2 again, shoe size 3, very small feet. Okay, so what we have here then is different shoe sizes, and what we would find is that, you see how it's humped in the middle? See the big pile in the middle? That means most people are average. And this isn't just for men's shoe size. This is for anything occurring in nature. If we, for example, went out to the giant lawns in front of the college and we grabbed leaves and we grabbed 1,000 or let's say 100 leaves and we brought them in and we measured them real carefully on the chemistry scales that can measure light things real precisely, we'd find some average leaf weight. I have no idea. Maybe it'd be 10 ounces, right? But not every leaf would be the same. Some are bigger, some are smaller. There'd be some standard deviation jump. Maybe it'd be up by, I don't know, 3 ounces. So then 13 ounces for this line, 16 for this, 19 for that. We could subtract the other way for the lighter leaves, down by 3, right? There'd be some standard measure. So the point is, it would fit with this hump in the middle. Notice most of the leaves with this hump in the middle would be average. Most of them would be right on the average or close to the average, just like men's shoe sizes. Most men have shoe size probably between 7 and 11. Again, I made this up. You could type into Google average men's shoe size in the United States and the standard deviation. You'd find it. So that means most men are going to have feet that are pretty average, somewhere between size 7 and size 11 shoe size. That's why there's the biggest pile right in the middle. Now, some people have really big feet, but see how the pile comes down much lower. Few people have really, really big feet. Up here, size 15, you're getting like NBA shoe size. And then you go down here, much smaller feet. You know, few people have really small feet, shoe size 3, maybe jockeys or something like that. So, all right, so the point is it's humped in the middle. It's bell-shaped, meaning most people are in the middle. Most people are average, most whatever, not just shoe size. We could measure, like I said, the weight of the leaves. IQs are this way, SAT scores, almost anything naturally occurring. If you measure it out, and you put the average in the middle and find the standard deviation, you'll find it fits this bell curve. It's very widely used in the professional world. This normal, it's called the normal distribution because it's so normal. It just happens all the time for almost everything occurring naturally. Humped in the middle. And so these percentages specifically apply, meaning if this was right, if the average man's shoe size really was 9 and the standard deviation really was 2, which I'm sure it's not quite that, but it's maybe close, that would mean 68% of all men have a shoe size between 7 and 11, and 95% of all men have a shoe size between 5 and 13, and 99.7, that's almost everybody, have a shoe size between 3 and 15. Or you can look at these percentages that fit in the various sections. All right, so there's the idea of the bell curve. Now, let me erase, having done all that, let me erase all this. And because I was doing it for men's shoe sizes and leaves and things. Whoops, I should leave all that there. Whatever. Yeah, let's get rid of this. So now let's do the particular example they're giving us. What are they saying? Fuel economy of automobiles, miles per gallon. There's a mean 26.8, that goes in the middle, right? That's the mean, that's the average, 26.8. That's the average car. It gets 26.8 miles per gallon. But there's a standard deviation, they're not all average, some are below and above by 5.2. That's the standard jump, that's line to line, 5.2. So you go up 5.2. So you type this on your calculator, you're going to get what? They're on 32.0, I think. And then go up 5.2 again, you're going to get, what is that going to be? 37.2, and then go up 5.2 again. It's like a number line, except it's got 26.8, the average, right in the middle, and then 5.2 again. What's that going to be? 42.4, I think. Yeah. All right. And now let's go down the other direction. So going for cars that get worse gas mileage than average, we'll go down by 5.2. Subtract 5.2, you get, what's that going to be, 21.6, right? And then next one, subtract 5.2 again. I'll do my calculator there. So 21.6 minus 5.2 again, getting 16.4. And then subtract 5.2 again, getting 11.2. So that's pretty low gas mileage. All right, so now what's their question? Within what range are 99.7 of the automobiles? Well, you can see down at the bottom, the 99.7 goes from here to there, doesn't it? So that goes from 11.2 to 42.4. From 11.2 to 42.4 miles per gallon. That means 99.7% of all cars get gas mileage somewhere between 11.2 and 42.4. This is highway driving. So yeah, even trucks and things get 11.2 at about. There's not many cars below that or above 42.4 probably. So 99.7% of all cars are in that range. So we can answer whatever the questions they want based on the percentages in the normal curve. So from example to example, what you'll see is the numbers on the bottom change. Like if they give us men's shoe sizes, this would have been 9 is the average shoe size, and standard deviation would have been 2, so it would be 11, 13, as I did a minute ago. The numbers on the bottom change, but the percentages don't change. 99.7, 95, 68, all these percentages, they never change. That's what it means to be a normally distributed. Those percentages are true based on whatever number you put in the middle, the average, whatever, shoe size, miles per gallon, weight of a leaf, average, and then the jumps here for the standard deviations going up and going down. Those change from example to example, but the percentages do not change from example to example.